So hi and hello, welcome to our channel in Algo Exploration. My name is Samir and this is the continuation of finding min-max algorithm. So today we will understand the finding of min-max algorithm in a given array using divide and conquer technique. So as I said earlier in the understanding of divide and conquer strategy, that while building an algorithm that follows divide and conquer technique, we should define the small problem first, also known as a base case in the recursive code context for termination. So here the small problem will be if the number of elements are 1 or 2. If the number of elements are 1, then the number of comparison will be 0. Due to this, we will return that element itself as minimum element and maximum element to its parent. And if the number of elements are 2, then we will compare these two elements and the minimum element will be get written as minimum and the maximum element will get written as maximum to its parent. So let's understand now by taking one example. Now this is an array of length 7. Now here, since we are using divide and conquer technique, we have to divide the whole array into subarray until we reach to a small problem. Now here the dividing will be, if the size of the array is n, then we will divide into two halves, n by 2 and n by 2. So this will be our dividing structure. Now here the structure of the tree will look like this. Now to find the mid index, the formula will be start plus end divided by 2. Here start is nothing but start index and end is nothing but end index. So to find the mid, 0 plus 6 by 2, that will be 3. So we will call 0, 3 and mid plus 1, end, that is 4, 6. Similarly here the mid will be 0 plus 3 by 2. So it will be 1. Now many of you will argue that 0 plus 3 by 2 will be 1.5, but actually we are taking the floor value, so that will be 1. So we will call 0, 1 and 2, 3. Mid plus 1, that is 1 plus 1, 2. And here the mid value will be 4 plus 6 by 2, that will be 5. So 4, 5 and 6, 6. So in this way we will call the function. Now let's see how we are calling it recursively inside the stack. Now let's name this function. This will be the root. This is C1, that is C11, C12, C2, right child of root, C21 and C22. Now initially the root will be, that will call its first child, that is left child, C1. Then the C1 will call C11. Now since it is a small problem, it will execute and return its value to its parent, that is C1, and due to this it will get popped. So let's delete it. Now after that C1 will call its right child, that is C12, and here also, now since it is a small problem, it will get execute and return its value to C1, that is parent, and it will get popped. So let's delete C12 also. Now C1 has both the values from C11 and C12, so it will return its value to root and this also will get popped. Now root has the value from its left child, so it will call C2. Similarly C2 will call C21 and it is a small problem, so it will return its value and will get popped. Now C2 will call C22 and it is a small problem, so it will return its value and get popped. Now C2 has both the value from C21 and C22, so it will return its value to root and it will get popped. And finally root also will get popped. So in this way calling happens recursively inside the stack. Now here you have to observe that since C11 and C12 are sibling, it will be reside in the same cell. Let's say root, then C1, then C11, and then it will get popped, and C12 will be reside in this cell only. And C1 and C2 are siblings, so C2 will reside in C1 spot. When this get popped, this will also get popped, so in this cell C2 will reside. Similarly, C2 will call C21 and C22, so in this cell only C12 and C22 will reside. Now let's solve the problem. Now the whole array will get divided by 2 until it reach to the small problem. Now at this level all the functions are having a small problem. So this is index 0 and index 1. Now the number of elements are 2, that is a of 0 and a of 1. So since we have 2 elements, it will get compared and the minimum element will get written as minimum and the maximum element will get written as maximum. So let's say we represent minimum as n and maximum as x. So first maximum element will get written and then minimum. So by comparing these two values, we find out that n is 27 and x is 83. So here 83 and 27. Now these two values as maximum and minimum will get written to its parent, and now this function will call its right child, that is this one. So index at 2, 3. So 2, 3 will be this. Now by comparing, we found out that x is 52 and n is 14. Now it will return x and n to its parent child. Now this function has actually 4 values: 2x, let's say x1, x2, and 2n, n1, n2. x1 has 83 and x2 is 52. Now n1 is 27 and n2 is 14. Now within these two there will be a comparison that who is maximum, and within this it will be a comparison that who is minimum. So here we found out that maximum is 83 and minimum is 14. So here in x place the maximum will be 83 and minimum will be 14. Now these values will return to its parent, and now the root will call its right child starting with index 4 and ending with index 6. Now this function will call its left child index at 4 and 5. It is a small problem, so we will compare it. We found out that x is 68 and n is 9. So it will return x and n to its parent, and now this will call its right child. And we found out element at 6th is 36, which is a single element, so it will return 36, 36. Because as I said, if the number of elements are 1, then we will not do any comparison, we will simply return itself that element as minimum and a maximum. So now this function has 3 elements. Let's say x1, x2, n1 and n2. Now x1 is 68 and x2 is 36 and n1 is 9 and n2 is 36. Now there will be a comparison between these two elements and between these two elements. Now we found out that maximum of these two elements is 68 and minimum of these two elements is 9. So 69 and 9, and we will return these two values to its parent. Now similarly here also this function has 4 values: x1, x2, n1 and n2. Now x1 value is 83 and x2 value is 69 and n1 value is 40 and n2 value is 9. Now there will be comparison between these two elements and these two elements. So your maximum is 83 and minimum is 9. So 83 comma 9. So this will be our result. So here we can see that the maximum is 83 and minimum is 9. So in this way we actually find the maximum and minimum element in a given array using divide and conquer strategy. Now let's see the pseudocode in the next lecture. So thank you.